Hello everyone, and welcome to this webinar from the Swiss Veratron headquarters. So it's really great to have you all here again, thank you for that, for this additional product presentation. Today we will talk about the LinkUp gateways. These are the devices that you see here next to me that I will explain throughout the presentation. I will show you we have different variants, and I will highlight all the differences and all the strengths of this product. So there is really a lot to talk about. Just before starting, let me just remind you not to forget to download the attachments, because there you can download all the documents regarding the LinkUp, regarding all the sensor, the data sheet, and all the technical data that you need to get to know the LinkUp gateways. So let's not lose additional time and let's deep dive into the LinkUp world. So let's start from an overview of the available LinkUp variants that we have. You might already know some, for instance the Resistive variant or the Pyrometer variant, as well as the first IBS variant for the battery monitor, because they were launched last year. And for these devices we were granted an innovation award at IBEX 2020. So today we'll be introducing more variants of the LinkUp, as it was already announced at that time. So in detail we will have, I will show you the new intelligent battery sensor for 12 volt and also the 24 volt variant. The LinkUp 2-in-1, which is a specific LinkUp variant designed to integrate a combined oil, temperature and pressure sensor. And last but not least, the J1939 to NMEA 2000 gateway. So before starting, let's just have a look about what a LinkUp is in its more general concept. So the LinkUp is a single function gateway which is designed to translate to NMEA 2000 a sensor reading. So you have a sensor that is connected to it, an analog sensor or also a digital sensor. Then the LinkUp receives the signal and processes the signal thanks to the configuration which is given to it, and it transfers the data on NMEA 2000, so you can see the information on your multifunction display or on your chart plotter or glass cockpit. The LinkUp can be used in both a standalone or a complementary to another gateway scenario. We will see shortly some typical use cases of it, or in case it is required to interface a specific sensor that is not supported by a larger gateway, for instance. So here we see a typical use case with outboard engines. For instance, NMEA 2000 enabled already, so there is no need to transfer all the engine data on NMEA 2000 because they're already there, but maybe it is just required to show the fuel tank levels or water tank levels and maybe the battery status. So you immediately see that for this traditional gateway with a lot of inputs, it's probably over-designed for such a system, and so that's when the LinkUp actually come into use. But not only, because as I said, the LinkUp is also very useful when used in combination to another larger gateway, so as complementary. You see here a use case with an engine box. This is an example of a typical dual engine, inboard engine setup, where you have really a lot of sensors, a lot of data that have to be transported to NMEA 2000. And already from this schematic, you see how fast a gateway, a traditional gateway, a big gateway, is filled up with information, because if you have two engines and multiple fuel tanks, it's really easy to fill up the gateway, like the engine box, for example. So here you might use the LinkUp to integrate the one or two sensors that are missing, or as it is shown in this diagram, when the specific sensor is not supported, like here in this example, the exhaust gas temperature or the battery sensor monitoring. So what are the general benefits of using a LinkUp? Well, so first of all, as we just saw, sometimes you save the money of an over-designed gateway when you don't need it. So you don't need a huge gateway when you don't have so many sensors on board. Secondly, being a gateway and a single function gateway, it reduces the wiring in the boat because the gateway is exactly installed where it needs to be, so where the sensor is. So if you also have just a central single gateway, you need to wire all the sensor to it. So with the LinkUp, you have a cleaner installation, so to say. Well, then a big benefit of the LinkUp is the contactless configuration. You might be already familiar with it because meanwhile we have integrated it in a number of products like the VL Flex, for example. Make sure to check it out as well. So you don't need expensive hardwares or external hardwares to connect, for instance, to your PC to program through a complicated software the gateway. But all you need is your smartphone with the Veratron application for the LinkUp. But we will see more throughout the presentation now. The gateway is also powered by NMEA 2000, so this is another huge benefit of the LinkUp because you don't need to wire any power to the LinkUp because the power is directly taken from the NMEA 2000 backbone. And last, but very important, is that the LinkUp is approved for engine compartments installation. We will see more about this because it's a very important topic, being a gateway which is installed in potentially hazardous environments like the engine room is, for instance. Here you have an overview of all the NMEA 2000 gateways that we have in our portfolio. So, as you see, we start from the engine box, which is the larger gateway that we have to date. So you see the number of inputs is very high. We go up to 8 resistive inputs, or 2 capacitive and 2 J1939 lines. And down to the OceanLink devices, because again, I want to remind you that all the OceanLink displays that we have in our portfolio contain an embedded NMEA 2000 gateway. So this is a real plus for our OceanLink devices. Not only the displays, but also the gauges. So you see here that from the engine box, we move to the OceanLink 7, down to the 4.3, which was initially designed for supporting one engine only, completely, to the OceanLink tachometer and speedometer, 85mm instruments, and then the LinkUp. You see here that is highlighted in yellow, and you see that the LinkUp is a single function gateway. So you have either one resistive or one J1939, or one LIN, which is used for the battery sensor, or PWM, which is another input which is used to interface the combined temperature and pressure sensors. So these inputs are unique on the LinkUp. So I want to shortly move now to the general overview of the LinkUp. So what are the common features across all the LinkUp variants? And first of all, we have the design. So the design of the LinkUp is the one you see here in this slide, or at least the central part, so the LinkUp housing, where all the device electronics is contained. You have the notification LED and the wireless interface to program the device, and the NMEA 2000 side wiring. So this is also common across all the LinkUp variants because this is the output of all the LinkUps. So this is a 30 centimeter wire pigtail with the standard M12 connector with 5 pins, and the power supply is also taken out of NMEA, as we saw. So these are the two very common part of all the LinkUps, and then there is the sensor side wiring, which is different depending on the variant that we will see, because it depends on the sensor that needs to be interfaced to it. We will see them when I will present all the variants later on. What about the housing? The housing of the LinkUp is realized in polycarbonate plastic housing, so there are no real big cosmetic requirements here, but most important, We have a high impact resistance, so robustness and heat resistance, which are more important for such a product. But the most important feature of the LinkUp housing is, as we saw before, that is approved for installation in engine compartments according to the ISO 8846. So this is achieved thanks to the bicomponent resin, which completely fills the LinkUp housing, making it air sealed, so no gases can sneak into the LinkUp housing to pose a potential hazard, especially if we consider that this device is designed to be installed in engine compartments, so close to the engine or close to fuel tanks. And as we all know, especially in inboard engines, fuel engines application, this is a really critical safety point. Let's come to the compliance. So all the devices, as every product developed at Veratron, is CE, REACH and RoHS compliant. So the housing is made out of flame retardant material, which is polycarbonate again, so according to UL 94 requirement. Another requirement which is very important in the direction of engine room installation, IPX7 protection class as an exposed device. Here we saw already that actually the device is even air sealed, so water intrusion is a easier requirement compared to that. And of course NMEA 2000 certified. So the galvanic isolation is also maintained between the power of the LinkUp and the power of the sensor. I want to spend a couple of words again, as I often do for NMEA 2000 certified devices, because all the LinkUps that you see today are certified devices. This means that all the LinkUps has been tested by the NMEA 2000 organization to be fully compliant with the regulation of NMEA 2000, and they ensure the interoperability between NMEA 2000 devices. So when you use a certified device, you are sure that your device cannot potentially damage the NMEA 2000 network, and the data sent by this device are read correctly by other displays, for instance the chart plotter. So this is something important I always want to remind you. You can go on the NMEA Association webpage and search for Veratron, and there you will see all the that are NMEA 2000 certified from our side. Just know the difference. Another big important feature is the wireless configuration. Actually, this is one of the killer features of the LinkUps, because as we saw, you don't need a lot of hardware, you don't need additional hardware for programming the device, but you just need your smartphone. So this is done in few steps. So the first step is to near the smartphone to the LinkUp area, so LinkUp wireless area. So you just near the smartphone to it, then the LinkUp type is read. You perform all the configuration of the sensors on your smartphone, on the application, in a very user-friendly and easy way. Eventually you can configure an alarm if you wish to, and then to download the configuration into the LinkUp, you just need to tap again the LinkUp, the smartphone against the LinkUp, and the program is instantly done. So that's really so simple. And this gives really a lot of advantages to the installer, to the final user, or to dealers, because this is, first of all, a very fast way of programming the gateways, because as we saw, no prior pairing is required. So unlike Bluetooth or Wi-Fi or other technologies, you can just take the phone, pick any LinkUp from your warehouse and just program it. It's super fast. Fast, but also powerless. This is another important feature, because inside the LinkUps there is no power required for the NFC antenna. So then the NFC tag is totally passive, and all the energy required for the programming is harvested from the smartphone. So you can do the programming also when the LinkUp is packed even. So if you think about this, is a great advantages for final sale, for example, at the counter programming. A shop, for instance, could just take a LinkUp out of the warehouse and program it for his customer without having even to open the packaging. It's secure because it requires proximity to the device to program it. So it's not like Bluetooth or other technologies that you can do from remote. So some man in the middle or someone could spoof the connection and just program your devices, but you really need access to the physical location of the LinkUp to program the device. So it's secure. It's secure, but it's also safe, and this is what is most important for us. So this is a passive NFC tag, what is into the LinkUp, which means that during normal operation, the LinkUp does not emit any frequency that is not needed. And again, being in the engine room, this is definitely a good feature to have, especially if we consider that the programming most probably is done once during the installation and maybe never again. So it would be really a waste of power, first of all, and an unneeded feature to have something that continuously emits radio frequencies, especially in such an environment. And also, as a last point, is a cost-effective way of programming, because you don't need, as we saw, additional hardware to program the devices, but you just need your smartphone. So this is all about the common features. I would like to quickly move on to see the variants of the LinkUp one by one, starting from the resistive variant. So the resistive type of the LinkUp is the most generic LinkUp variant that we have. I say this because it is able to interface really a lot of sensors, from engine monitoring to tank monitoring sensors. We will see later during the configuration all the possibilities that you have, all the sensors that are supported by this LinkUp. More in general, the hardware is able to read in a 0 to 400 ohm range, so all these sensors within this range are supported, and this is the range where the LinkUp hardware is most accurate in the measurement. But anyway, this is also the bandwidth where most of the sensors deliver their signals. So let's have a look how this LinkUp is designed. On the sensor side, we have this 25 centimeter pigtail for the sensor connection, which ends with this AMP super seal 2 poles connector. There are several reasons why we chose this connector for this LinkUp, being so general. The first one being that is a very good connector, really reliable, fully water sealed, and with very good mechanical properties, which is always good to have, but also because it's widely available on the market. So this is, from an installation standpoint, also a big advantage when you have to connect to this LinkUp another sensor which does not have this connector. It's really easy to find its counterpart on the market. But this is not the case for our deep pipe level sensors that you see here. So these sensors are already designed with the counterpart of that LinkUp connector. So to interface this tubular level sensor is just enough to snap in the LinkUp. It's so easy, so the installation in this case is fully plug and play, and just with this simple operation you have a fully NMEA 2000 certified level sensor. So when it comes to the configuration of the resistive type LinkUp, all you need to have is the app. So here you see the LinkUp Configurator app for smartphones. And here you have immediately an overview of all the sensor types that are configurable on this LinkUp variant. So from all the levels, fuel, fresh water, wastewater, trim and rudder, all the temperature and pressures from the gear, from the engine, or the trim tabs also. So let's just pick one just to try out how the configuration works. So Let's pick the fuel level, which is the deep pipe sensor, which I have connected here on this installation. So as you see, as soon as you select the sensor type, you are presented some standard configuration for it, which are all the standard curves for a fuel level. So you see here you have the American standard or the European standard for it, and also lastly you also have the custom configuration, which allows you to program a custom curve in case you're using a sensor which is not listed here. So let's now pick this configuration. As you see here, you can always manipulate the configuration, the standard configuration. You see here that when you press this characteristic, you are presented this table where you can basically manipulate all the ohmic values in 5 points, so you can fine-tune the standard calibration of this sensor in case you have a specific tank, for instance, with a specific shape, special shape, so the levels are not anymore linear. So here you can manipulate every configuration. So then for the fuel, you can also set the tank number. Here it's now tank 1 selected. Let's just pick, I don't know, tank 2, and done. And this is it. This is how the configuration is done on the LinkUp. All you need to do now to download the configuration is just press Write Configuration and then tap onto the device on the LinkUp, and as you see, it is instantly programmed. So you see also that in the installation I have here, instead of an NMEA display, I have a tablet connected to the Veratron Go that I have in the system here, and you see that the Fuel 2 level just appeared. So we can do it again. We can see that you can change this. You can change this to tank 1, for instance, and once again program the LinkUp just with a tap. You just have to near the phone to the LinkUp and it's instantly programmed. You see that the fuel 1 is already taken over as data, so the configuration has an immediate effect on the LinkUp. It's immediately taken over. Another thing I wanted to show you, and I already anticipated before, is the possibility of programming the LinkUp passively. So actually this makes it possible to program it even when the LinkUp is still into its packaging. So as you see here, I have a standard packaging including the LinkUp, and it's of course not connected, but thanks to the passive antenna which is embedded in the LinkUp, you can still tap on it, read the configuration. You see now the configuration was correctly read. At the beginning, no sensor type is configured, and I can change to whatever I want. I can say a fresh water level for tank 1, write the configuration, and configure it. So now this LinkUp, this new LinkUp, is basically programmed without being powered. So that's all it takes to program a resistive type LinkUp. Let's have a look now at the Pyrometer variant of the LinkUp. This is a specific LinkUp variant which is designed to only interface our Pyrometer thermocouple. This is the sensor, this is the probe. So we have this sensor available in our portfolio since a long time, since many years. There were specific gauges designed to read the values from the sensor, and now thanks to the LinkUp it is possible to have the exhaust gas temperature data available on NMEA 2000. Some information about the sensor. So this is a high precision probe designed for measuring the temperature of exhaust. It delivers a very special signal, very tiny in amplitude, and basically that's why we had to develop a specific LinkUp variant for reading the data from this sensor. Because of this, it has electrically compensated wires to avoid attenuating the already small signal too much, and yeah, needless to say, it has to withstand very high temperatures. So more in general, what are the benefits of using a pyrometer system? This is common in commercial applications because reading the pyrometer can be an early warning of situations that are potentially dangerous to the engine. So by reading the exhaust gas temperature when it is above the range, it can help preventing more severe damages to the engine for a number of reasons. So all in all, when you have a correct setup for your engine by reading the pyrometer sensor, it also helps to improve your fuel consumption on board. But let's go back to the entire system. So the LinkUp for the pyrometer looks exactly as the resistive type. It has the same AMP connector on it. So from outside you cannot tell the difference between the two, but this is, as I said, very specific for the pyrometer only. We offer this system as a kit. So it includes everything you need to mount the pyrometer system. So the LinkUp here is included. The sensor, of course, is also included with all the accessories that are needed for soldering the probe onto the exhaust gas manifold, and also a 6-meter extension cable. So this cable also has the AMP connector, so the connection to the LinkUp and also to the pyrometer is completely plug and play. You don't have to do any electrical or manual work. And it is also a special cable because it can withstand very high temperatures, which is the case where the pyrometer is installed, so leaving then the LinkUp a little bit away from the heat source. So this is everything you will find inside the pyrometer LinkUp packaging. When it comes to the configuration, well, there is not much to show about the pyrometer because, of course, being so specific for pyrometer, it is not possible to set the sensor type because it's fixed to the exhaust temperature. It is only possible to set the sensor instance in case you have more pyrometers on the vessel, and it's possible to set an alarm. So you will get the exhaust alarm on your multifunction display, or in case if you're using a gateway like our Veratron Go, you can receive notification directly on your smartphone wherever you are on the boat. I would say that's it for the pyrometer. I think that if you're interested in more details about the sensor or the kit, you can find them all in the attachment of the webinar. So again, make sure to download them. And at this point, I would move on to the probably more interesting intelligent battery sensor. We offer 3 systems for intelligent battery monitoring. 2 for 12-volt battery systems and 1 for 24-volt batteries. All these are based on this sensor here, which is the intelligent battery sensor. It is an electronic sensor which sits on the pole of the battery and sees all the current that is being charged and or consumed by your systems in your boat system, and with the data that it provides allows you to carefully plan your energy requirements aboard, as well as to do some preventive maintenance on your batteries or your battery packs, for instance by reporting the state of health of your battery. So this delivers real-time measurements, and with this you can also prevent phenomena like overcharging or overheating of your batteries with all the data that it delivers. So let's have a short look at which data are actually delivered by the sensor. So by sitting on the battery, it can directly measure the battery voltage, the current, outgoing or incoming current in case of charging, and the battery temperature. And then by interpolating this data with the data that you have provided through the LinkUp, so the configuration basically of your system, in terms of capacity or battery type, so we will see them just shortly. It is able to deliver some more sophisticated informations, like first of all the state of charge, which is the percentage of charge of your battery, like the charge of your phone, for instance, or the state of health also, which is basically representing the aging of your batteries, so how good your batteries are still. And this is possible because the sensor witnesses basically all the charging and discharging cycles, and is able to understand whether the battery has lost some of its nominal capacity or not. And also it delivers the autonomy of the battery, which is also very important to avoid being left without batteries while on a journey. So this is the battery consumption, based on the battery consumption in real time that the sensor can detect. So how is this sensor communicating to NMEA 2000? Of course through the LinkUp. So the LinkUp also in this case is very specific, and it looks like this. So at the central part you always have the housing and the NMEA connectors, and then on the sensor side you have all the dedicated harness for interfacing both the battery on the battery sensor and the positive poles of the battery. So in general the sensor is sitting on the negative pole of the battery, and the LinkUp is also connected to the 12 volt positive pole. This system is also delivered as a kit as well, so it includes several components. So there is the LinkUp, of course, and the battery sensor as well. And then to help also the installation, to make it very easy, the integration, we also deliver a battery post adapter, which it's then placed on the ground bolt of the sensor, and it allows just to simply remove the ground utilities from the batteries, install the sensor, and just plug back the cable onto the pole adapter here. So the sensor itself, as I said, is mounted on the negative pole of the battery. So we have two sensors here for 12 volt. One was already announced last year and launched. Now we have a second variant, which is a generation 2, so-called, which features a higher capacity, up to 500 ampere hour capacity for a battery, which is far beyond the maximum capacity of most of the batteries available in the market. And then, as we saw before, there is a fused connection to the positive pole of the LinkUp to get the voltage, of course, and to get the power for the LinkUp. While for the 24 volt system, normally the 24 volt is realized by having two 12 volt batteries placed in series. So the LinkUp needs to be connected to both these batteries, to both the positive poles of these batteries through the fused wires that are provided on the harness, and then it is able to get also the power from the 12 volt and to monitor the 24 volt overall voltage. Let's have a short look at the data sheet. So as we saw, we have three variants of the battery sensor. Basically they differ in the nominal voltage that they support, 12 or 24, and the capacity, while the battery types which are supported are all the same across all the three variants, which are the standard lead acid batteries, gel batteries, and AGM batteries, which normally have higher capacity because they supply energy for all the onboard utilities. This is how the configuration for the battery sensor system is done. So again, with the LinkUp Configurator app, once you open the app and you tap on the device to read which LinkUp type is that, you are shown the three possible sensors, battery sensors that are connected to the LinkUp. you see that you have the two 12 volt, the generation 1 and then generation 2, and the 24 volt. So let's use now the 12 volt generation 2, which is the one that I have connected here in my setup. And let's have a look at the configuration possibilities that the app presents. So this is basically all you need to input for setting up correctly your system. First of all, you need to set the battery type, and you can choose, as we saw already, between the floated, the gel, or the AGM battery. Let's select the AGM battery, which is the battery that I have installed here, and then we have to input the battery capacity here in ampere hours. We have here a very small battery, so it's 38 ampere hours, and then the battery number. So you can address all the battery sensors on your NMEA 2000 network by setting correctly the instance here. So it's battery 1 up to 4 batteries. So we select battery 1, and once again, as we already saw, all you need to do now is to press right configuration and then tap on the LinkUp device, so to have it immediately configured. This is really easy, and it can be done simply with your smartphone app, and these are all the configurations that basically your intelligent battery monitoring system needs to have to properly work. The next LinkUp variant I want to show you is the 2-in-1. It's called 2-in-1 because it is able to interface our combined oil temperature and pressure sensor. This sensor that you see here in my hand. It's an electronic sensor derived from the automotive market, and as you can imagine, the big advantage of this sensor is that it can replace 2 other sensors. So by using this one, you can replace 1 temperature sensor and 1 pressure sensor. The design of the sensor itself is really compact, so this is even more clear if you compare it, for instance, to a standard electromechanical pressure sensor. So you see that the difference is really clear here. The sensor itself comes from the automotive market, so it's a fully reliable, rugged design and designed for harsh environment to operate. It has an ASIC, so it's controlled by a microprocessor inside here. The microprocessor takes the signal from the oil and delivers to the LinkUp a PWM signal, which is a digital signal that is taken from the LinkUp, it's processed, and then the value are sent out over NMEA 2000. When it comes to the range, the sensor can withstand temperatures from -40 to 160 degrees, while in the pressure, the sensor can support from up to 10.5 bars with an overpressure detection up to 60 bar. I have some other data out of the datasheet, but for this I really suggest that you download in the attachment the full datasheet so you can have a complete overview of what the sensor can do here. Basically, it has an M12 thread mounting option. It's fully water sealed, so it's an IP69K protection class, and it's electronic, so of course it requires 5 volt to operate. But anyway, you don't have to bother bringing this voltage to the sensor because the LinkUp does it all. So it provides the 5 volt and it receives the signal, so no additional wiring is required. What is remarkable to say now is the accuracy, because this is one of the big strengths of this sensor. In the temperature accuracy is plus minus 1 degree, which is really low. And in the pressure area, it's down to 0.1 bar, or 0.2 or 0.3, depending on the pressure range which the sensor is measuring. In regards to the connection of the LinkUp, well, this is once again fully plug and play, so the mating connector is provided on the LinkUp sensor cable, so you can simply connect the sensor here and the installation is done. Electrical installation is done, and on the sensor side of the LinkUp you have a 1 meter cable harness to connect to the sensor. So the configuration actually can be done as always in terms of sensor type, because depending on where the sensor is installed, the LinkUp can deliver the engine oil or the gear oil, temperature and pressure. Of course, besides this, you can configure as always the sensor instance if you have more than one, and the alarm threshold. I would say this is it for this variant. Again, I highly suggest that you download the attachment to see all the features of the sensor, all the data sheet. And I would like to move on now then to the next variant, next and last variant for today, which is the J1939 LinkUp. The last LinkUp variant for today is the J1939 Gateway. So as the name suggests, this device is developed to transfer all the information that are delivered by the CAN engines to NMEA 2000, so that are available on your boat network. The LinkUp delivers all the data that are transmitted, but also all the alarms that the engine transmits through the DM1 messages, for instance. So you can always have all the alarms available on your chart plotter or on your NMEA 2000 display, or also, which is another nice solution, if you're using our Veratron Go gateway, you can receive them directly on your smartphone. Important to know about this LinkUp variant is the galvanic isolation that is foreseen on the hardware. This is due, of course, to the NMEA requirements for being certified, but then this implies that any issue that occurs on the J1939 network won't affect at all the NMEA 2000 network, and it won't damage your system and your other devices that are connected to that. This LinkUp is designed with this connector, which is a Deutsch connector with 4 pins. We use this connector because it's widely used on CAN engines to connect the J1939, so this is the most common connector for J1939 networks. So also in this case, in most of the cases, you're able to do this installation just plug and play, so to install the LinkUp on a free J1939 port. But anyway, we are also developing some accessories, some optional Y-shaped cable, so that will change this connector to a specific other connector to interface different engines and different engine manufacturers. So the Y-shaped cable connects to the LinkUp, and it connects then to the J1939, and it optionally also allows you to keep the original instrumentation on the line. When it comes to support the data, well, this LinkUp supports most of them. You see here a list. You have a list of all the data that are supported. You can program wirelessly, of course, as always with the LinkUp, selectively which data you want to be transmitted from J1939 to NMEA 2000, in case some engines are not supporting some so-called SPNs on J1939. So with the smartphone app, you can choose which data to transfer and also which alarms to activate. You see here also a list of alarms that are supported. These are the most important ones, I would say. And there is also the transmission of the generic alarm, because in case a specific engine does not send an alarm which is not recognized by the LinkUp, the LinkUp is anyway able to send over NMEA a generic alarm just to tell the user that something is wrong on the engine, and provides the mill lamp activation or the engine red alarm on NMEA 2000 as well. As a last thing, let's also have a look about how the configuration of the J1939 variant is done. So when you read the LinkUp, this is the configuration summary you're presented with. So you see that here you see the source and the NMEA instance output written, and a summary of all the SPN data that has been activated. when we go to change configuration, then we can basically change all these settings. So for each engine, like if I have the first engine, engine 1 here, I can select the J1939 source, because as you know, practically in the market, even if there are two J1939 engines, they are never connected together just on a single bus. So there are two buses independently coming to the cockpit. So here, if you have two engines, like in this case, you need, of course, to use two LinkUps. So here you can say which is the engine you want to listen from and where you want to address it on NMEA 2000. So this is basic instancing, which is done here. And then below you can set up which data you want to transmit over NMEA 2000. So you see here all the supported SPNs that are listed, and one by one you can tick mark them and activate them. When you activate one of these SPNs, automatically also the DM1, so the diagnostic message or the error message tied to this SPN, will be activated. In the first item you see the check engine, which is the generic alarm which I was talking to you before. So in this case, when we turn this on, the LinkUp will also listen to all the alarms that are also unknown alarms that are coming from the J1939 line, and will address it as check engine on NMEA 2000. So this is what you can do once you're done with your basic configuration, because more is not needed. This is already from a digital bus to another digital bus. As always, as we already learned, you have to press Write Configuration and just tap on the LinkUp to have it programmed. And as you see here, now I get the new configuration summary, and I see only the SPN which I have activated as on, and all the SPN not active as off. And as I did it now, I did it also powerless. I did this configuration powerless because you see here I don't have a real simulator of a CAN engine, so the LinkUp is completely non-powered, but still you can do the configuration. And with this last variant, it's everything for today. Thank you for listening to me all this time. I hope the information was good, and you find that the LinkUp device is a nice product, at least as much as we do. If you want more information about them, download attachments. Do not forget to do so, because you have all the documents related to the LinkUp and to the new sensors. Or, of course, you can also watch the webinar again if you really like it. It will be shortly uploaded on our YouTube channel. So make sure also there to receive the notification, to be always up to date with our latest product launches. Or ultimately, of course, you can always contact us, or you can contact any of our dealers. So that's really everything from my side. Once again, thank you for joining. Stay safe and see you next time.